Hello my friends and welcome to this new practical tutorial where this time we're going to get separately our inputs and output. So first we must ask, why do we need to do this? Why do we need to do this specific step? Well, that's because of the next step. In the next step we're going to create a training set and a test set, and to do so we're going to use a certain function which will return the training set and the test set, but expects as input, well, exactly those, the input and the output of our data set, and that's exactly why we need to get them now. So let's get them first, and let's start with the inputs. So we're going to create a first variable, which we're going to call x, and that will represent exactly our inputs in an array. And in order to get those inputs, we're going to use a function called from our data set, which will extract by the index all the rows of this data set and the first 4 columns. Alright, so let's do this. Let's call our data set first. Then remember, in order to call a function, we need to add a dot here, and then the name of the function, which is iLoc. Right? I means index. It means that you're going to extract all the rows and first 4 columns of your data set by locating them by the index. Okay? So let's press enter here. Then we need to add square brackets, and inside those square brackets we need to enter 2 inputs. First is going to be the indexes of the rows that you want to extract, and the second input is going to be the indexes of the columns you want to extract. So let's start with the rows. A trick to select all the rows here is to use a colon, because this actually means a range, right? And because we're not specifying a lower bound of the range and an upper bound of the range, that means the whole range of rows. Basically, we're going to extract all the rows. Okay, so that's for the first input. And then for the second input, which we have to separate by a comma, well, we're going to enter the indexes of the columns we want to extract. And since right now we're getting the inputs, well, the indexes are all the indexes from 0, because in Python indexes start at 0, to index number 0, 1, 2, and 3. So a way to do this would be to do 0 colon 3, right? But there is a trick to do it more efficiently, especially if you want to make this implementation in the form of a template, so that it can be applied to any data set without you having to change anything. Well, the trick to do this is to remove the 0 here, and then to remove the 3, and just add -1. And what does this mean? It means it will extract the whole range of columns here except the last column, right? -1 means the last column. And it is excluded because in a Python range, the lower bound is included, but the upper bound is excluded. And that's why, this -1 here, which is the index of the last column, is excluded because it is the upper bound of our range here. All right, and so now whenever you have a data set, you can directly execute this, and this will extract all the inputs of your data set, provided, of course, that you have your dependent variable in the last column, which is usually the case of most data sets. Okay, so here is for this little trick, and then we just need to add a dot values here to extract our inputs in the form of an array, because that's exactly what expect the function here that will create the training set and the test set. Okay, and that's it. We have our inputs now, so we can play this cell, meaning run it. And now we're going to add a new code cell just to have a quick look at what we created. So we're just going to type X here to make it efficiently. We could do a print also, but this will work too. And as we said, indeed, well, it contains the first 4 columns of your data set, meaning the input, or remember the independent variables, right? These are the same values, and all the rows, right? These are the 3 last rows of our data set, which we can't see here because it displays the 5 first rows. And very important, this is an array, and that's exactly the format that is expected then, not only actually by, the function that will create the training set and test set, but also by the class that will build the model in part 2. But we will see that later. But anyway, you always need to work with arrays when you do machine learning implementations. Okay, so now we're going to do the same for the other entity that we have to create, meaning the output. So we're going to create a new code cell, and I'd like you to actually press pause on the video and try to create that variable of the output yourself. It's almost the same as this, but if you understand that this means a range and this means the last column, you will probably figure out how to extract that dependent variable. Just know that we're going to call it y, and now please press pause on the video to try to extract it yourself. All right, so let's do it together now. So first we have to call our data set, of course, then add a dot, then use the iloc function again, then square bracket. And now, according to you, what do we need to put as the inputs? Well, let's have a look again at what we want to extract. We want to extract, of course, the last column here, PE, which is what we want to predict. And so first, well, we need to get all the rows, of course, so this won't change. In the first input, we'll add a colon, which I remind means a range from first row to last row, meaning all the rows. And then for the second input, well, if you understood that this means the last column and that you actually don't need a range of columns to extract but only one column, well, the trick to extract the last column is simply to add -1 here, because this means exactly the last column. All right, and then of course, you didn't forget to add dot values to extract your dependent variable as an array. Well, in fact, as a vector of one dimension. Okay, so now we're going to create a new code cell. Okay, we're going to run the cell first to see if it works. Good. And then in this new code cell, we're going to enter y just to have a quick look at y. And here it is. You see it's an array again, but I called it a vector because this time it's horizontal. And that's exactly the format expected by the future functions we're going to use here and in part 2. But there you go. That's your dependent variable in an array of one dimension, right? Let's have a quick check. The first value here was 463.26. And there you go. That's the same first value here as well. Okay. All right. So that's it for this tutorial. That's all we needed to do to get our function ready to create the training set and the test set in the next tutorial. So I'll see you in this next tutorial to do this. And until then, enjoy machine learning.